Okay, now things are going to get a little more complicated. This is independent versus dependent events. So really what you're talking about is one thing occurring and then something else happens right after it. So the two things we're talking about here are independent if the first one and the second one have no correlation whatsoever. So whatever happens in the first event, it's not going to affect what happens in the second event. It's not going to affect the probability. So a quick example would be if I were to spin a spinner and then flip a coin. Those are two totally separate things. So no matter how that spinner lands, it's not going to affect what happens on the coin and vice versa. So best way to look at it is to, let's do some examples. Now, like before, we did an or situation where this could happen or this other thing could happen, and we added. When we have two things that have to happen, this happens and then this happens, we're going to multiply our probabilities. So if assuming that A and B are independent, they're not going to affect each other, then the probability of A and B happening is the probability of whatever A is times the probability of B. So let's look at an example here. So the container has 6 red marbles, 3 green, 5 blue, and 2 yellow. If a marble is drawn, put back in the container, and then another marble is drawn, what's the probability of drawing a red marble and then a yellow marble? And this brings up a phrase that you'll need to be familiar with. It says when an item is drawn and then put back, this is called with replacement. So that means you've drawn it, you replace whatever that is, and then you draw again. So everything is intact. So first, what's our sample space? We want to do probability of red. Is that right? Yeah, red, then yellow. So that means we need to do the probability of getting a red marble times the probability of getting a yellow, L-O, yellow marble. The first thing is, how many total marbles do we have to choose from? So if we count these up, we have 6, 3 makes 9, 5 makes 14, and 2 more makes 16. So we have 16 total marbles. Out of those, how many are what we want, which is red? There are 6. Okay, now remember we pulled out a marble, but we're going to put it right back in. So on your second draw, your sample space is still 16 because you put back that red marble. So what's the probability of getting a yellow marble? Well, there are 2 yellow marbles. So we have a 2 out of 16 chance. We multiply and we get 12 over 256. That's what 16 times 16. Simplify these two, and that will be your final answer, which is 3 over 64. So you have a 3 out of 64 chance of getting a red marble, then a yellow. Okay, same situation. Now in this case, we'll use green since we're talking about green marbles. If 3 marbles are drawn with replacement, so one is drawn, put back in, draw another, put it back in, draw another, what is the probability that all 3 marbles are green? So we want probability of green, green, and a green. So that means the probability of getting a green marble times the probability of getting a green marble times the probability of getting a green marble. So let's look back here because I've already forgotten how many green marbles are there. There are 3. So again, how many marbles are there total? 16. Out of those, there are 3 green. Now the next draw, remember you put back that green marble. So there are still 3 marbles to choose from, 3 green marbles, and 16 marbles total. And again, you put it back and draw again. There's a 3 out of 16 chance. Multiply those out, we get 9 over 4,096. And that cannot be simplified anymore. Okay, I'm going to let you take the last one pause here, go ahead and do that last one on your own, and then check back in a second to see if you're right. Okay, so let's see how you did. If we have a blue then a green, that's the probability of picking a blue times picking a green. So we have 5 blue marbles out of 16 times 3 out of 16 for the green. Multiply, that's 15 out of 256. You can't simplify that, so that is your final answer. All right, good deal, good deal. Let's go on. Let's talk dependent. Now this is where it gets a little bit different. So if events are dependent, that means whatever's done first is going to affect what happens next. So if A and B are dependent events, then we'd have the probability of A and B happening, just like before, but we figure out the probability of A happening times the probability of B after A has occurred. So you have to take into effect what just happened here. So let's look at that same marble situation. A container has 6 red marbles, 3 green, 5 blue, 2 yellow. Find the probability of drawing a red marble, then a yellow marble without replacement. So that means you draw the first marble, keep it out of the container, then draw a second marble. So this is the only difference between this and number 1 is that we're not replacing the marble. So let's take a look. Probability of red, then yellow. So we want the probability of getting a red marble times the probability of getting a yellow after the red has been drawn. So you got to keep that in mind. So probability of getting a red, we had 16 marbles total. There were 6 red. Now, remember, we kept that red marble out of there. So now, how many marbles are left in the container? This is where the dependent part comes in. If I draw a marble, keep it out of the container, that means there are only 15 left to choose from. Out of those 15, how many are yellow? There are 2. So we have a 2 out of 15 chance of getting a yellow after we pull out that first marble. So we're going to multiply, and this is going to give us 12 over, I believe that is 240. Yep, 240. Simplify your fraction. We get 1 over 20. And so you have a 1 out of 20 chance of drawing a red, keeping it out, and then drawing a yellow. Okay, let's try number 5. This is just like number 2, except we're not replacing. So if 3 marbles are drawn from the container one at a time, so draw one, draw another, draw another, what is the probability of drawing a green marble, another green, and then another green if each is not replaced? Okay, so we want probability of green, green, and green. So we have to take the probability of the green times the probability of a green after a green has been drawn, and then the probability of a green after, really after 2 greens have been drawn. So first part is the simple part. Probability of drawing a green marble. There's 16 marbles. 3 of them are green, right? Yep, 3 green. Okay, now this is where you have to be extra careful. Remember, we took out a marble, and we're assuming that it's a green marble. So now, instead of just 15 marbles left to choose from, we're assuming that the first marble is green, so how many green marbles are now left? There's not 3, because remember, we kept that one out. There are now 2 green marbles left. And then if we keep that green marble out, how many total marbles are left in the container? There's 14. How many of those are green? Hopefully you said 1. So now when we multiply those, that means 6 on the top, and then the bottom number would be 3,360. Simplified is 1 out of 560. Those are slim chances You have a 1 out of 560 chance of drawing 3 green marbles if you don't replace. Okay, I want you to pause here. I'm going to let you try to do number 6 on your own and check back in a minute to see if you are right. Okay, let's check. If you draw a black, remember you're going to keep it out because you want a pair of socks. So if you find a black one, you keep it, and then you pull out another black one. So you have a total of 16 socks, 10 black, 6 blue. The chance of pulling a black on the first draw, there's 10 black out of 16. Now keep in mind you keep that out. So now there are 15 socks left. 9 of them are black. So you get 90 over 240. Simplified completely is 3/8. So you have a 3 out of 8 chance of getting a pair of black socks. All right, and there it is. Now, after this, you should go to 97 worksheet 97C, and that is your assignment based on independent and dependent events. All right, good luck. Let me know if you have any questions. See ya.